Okay, so welcome back. So what we're going to do, we are going to create the structure of this for the node or tree in the Java. Before that, let's understand one thing. So we know that there is a one node. Okay, this node is having two parts. One is the data, the value of this node, and one is the left pointer reference and right pointer reference. Correct? Or left child or right child. Then this left is pointing to the one next reference. Remember that, right? Then again this is going to point some node. This node is going to have another data, and again left pointer and right pointer, again next reference. Correct? So we see next is nothing but next is a node itself. I mean structure will be same, right? Because this is also a node. So each node contains three things: a value and a reference to the left child, and a reference to the right child. Correct? So okay, so let's see the Java code for this now. So I'm going to create one class for this. I'm giving the name of this class is tree node, right? And this tree node is having three fields: one int value, second reference left pointer, reference pointer, if you remember, right? So that is nothing but is the same class, same data structure. So tree node, that is left, and another tree node, that is right. Fine. And since whenever you're going to create one complete node, that required three parameters, right? Tree node. So I'm going to create one constructor. Let me right click over here, generate constructor, and I'm going to use all the three fields, right? Okay, but initially when I'm going to create a root node, at that time left or right pointer is nothing, it's not available, so it will be pointing to null. Remember that, right? So I'm making this null. So this is the structure of a tree node. So if you compare, each node is having three fields: value, left and right, and left is nothing but it's a reference to the next node. Okay, so next tree node, so that's why I have taken the type is tree node. Okay, so now suppose I'm having one tree 10, and the left child is 5, and the right is supposed 15. Okay, and this is my root node. 10 is the root node. So let's create this. Okay, so I'm going to, using this class, I'm going to create one node. So what I'm going to do, I'm going to create one main class here. Okay, in main class what I'm going to do, I'm going to create a tree object with root value. Okay, tree node equal to root, that is equal to new tree node new true node. Suppose I'm going to give this value 10 because root is 10 for me. Correct? And root node is having nothing but is null, comma null, right? Left and right pointer is not available at that time. Now I have to set the left and right explicitly. So left I am taking 5 and right I am taking 14, right? So what I'm going to do, root dot left, that is equal to new tree node, left is 5, right? 5 comma null comma null. and root dot right, that is equal to new tree node. Again I'm going to give 14 here, right? So let me add 14 comma null, correct? So I have created my tree. So this is how we normally structure the tree. This is the way we create the tree. So root is object created, root dot left is point to the new node, that is 5, and root dot right, that is pointing to the new node 15, that is the right one, right? So this is just object linking we have done, right? If I have a little bit bigger, okay, suppose you are going to have in this example, let me give the left is also a node, right? So left is 5, so 5 is having suppose 2 more node, so 5 left is having suppose 2, and right is having suppose any number, you can take 7, okay? Then what? So let me add in this more. So what I'm going to now, 5 15 I am already created, so now I'm going to do root dot left. Root dot left means 5, but I have to add left of the 5, so I have to add 2 left, right? So 2 left. This is how we are going to link new tree node. I'm going to give the value like 2 comma null, and in the same way root dot right, root dot right means left of 5, root node is 10, right? Now 5 left is 2 and 5 right is 7, right? So first from the root I have to go left, that is nothing but that's a 5, then I have to move the right, so right, that is equal to new tree node. I'm giving the value 7, right? 7 comma null, right? So this is the whole concept how to create the tree. So let me repeat this again. So a tree is not stored like an array or list. Instead it's built using the object, right? So each node is in the tree contains 3 things: value, reference to the left child, and reference to the right child. So essentially every node is again a smaller tree, you can say a subtree. So this is what makes tree recursive data structure. Okay, so like in this I have created one class like tree node which have a value and 2 pointers left and right. Whenever we create a new node, its child are initially null, right? So we are going to build again a small tree. So we create a root node with value 10 in this case, then we attach the left child 5 and right child 15. That's it, right? So we have created this tree using the object reference, and for the next value that I've added, left of 5 is 2 and right of 5 is equal to 7. So in the same way I have just taken the path from root, where is this element should be, the left element should be root dot left, and right element should be root dot left right. Okay, so we have written this. Now the work is not over here. Now the main problem is how to read this data now, right? I have created my tree, but somewhere I have to process this data, so I have to read this. So for reading we are having multiple patterns that it talked about, DFS and BFS. Okay, so let's talk about DFS and BFS in the next lecture. Okay.